Good morning, guys. It's Thursday morning. I hope y'all are doing good. There's a wave at you. We're going to try to go over our material lesson 1 on waves today. Apologize for all the little confusion. We're trying to learn this, but having y'all try to tighten those text boxes was not probably a good idea. So if you're doing this on the computer, like I assume you are, if you can print those pages out, you can, but that's a lot of pages also. So just read it, grab your sheet of notebook paper, write down your responses, and have them ready for when we go over it. And again, if this gets too long today, I may break this up into more than one video instead of one long video. But let's talk about waves this morning. Alright, waves. Number 1, you are supposed to identify what is a wave. A wave is a disturbance that transfers energy from one place to another without transferring matter. Now they show you a picture here of the water and wave direction. The wave is coming along here going in this direction. This little person's bobbing up and down here. Don't let this picture confuse you, because real ocean waves aren't just transverse waves like this, but and this is not where, if you've got to go to the ocean like I got to when I was your age, we used to go camping down there, and my brother and I would play in the waves. I mean, we played where it broke over, and that's getting into water power. We had little styrofoam surfboards. We would ride the waves back to shore and end up down the shore most of the time. So there's a bunch of currents going on, different things. As soon as that wave breaks over, you're talking about water power, and yes, you're going to move with that. A lot of things. Even out, this is like kind of back away from where the waves break. You still have a bunch of currents going on in the ocean. So don't let this confuse you. What we're talking about here, energy transfer. So energy is what's transferred, not matter. Okay? How waves transfer energy? Like all material, water is made of tiny particles. So when an object hits the water, the impact of the object hitting the water transfers energy to the water, pushing and pulling on the water particles. So the particles are then transfer energy outward as a wave. So number 2 up here, what do waves transfer from one place? You were supposed to put energy. And on number 3 right here, describe what happens to the raft shown in the figure when the wave transfers energy to it. You're supposed to talk about it going up and down. Number 4, what happens to water when an object hits it? The energy is going to be transferred to that water in the form of waves. Trying to find where this was typed out so you wouldn't have just listened to me answer. Here we go. Here are the answers to the first to your questions that you were supposed to answer as you read. Alright. So we went over 1, 2, 3, and 4 right there. Alright, then moving on. And if you have your book, there's a few more pictures in your book. I may show you some of those off and on as we go through this. So there are different types of waves. We've got mechanical waves. So if you were able to tie the string to the doorknob and try to make these waves, as you flip that rope or string up and down, you're creating this wave, and but it doesn't travel the wave. If you create one wave, it's going to travel towards the door, away from your hand. So that's what mechanical waves. So a wave that can travel through matter is called a mechanical wave. Now what does that mean? Can travel through matter. Well, that wave is going along that rope. Okay? That's the type of matter. Air is a matter. So when you get into a vacuum, though, and where there is no matter, like space, where there is nothing, sound, which is a mechanical wave, cannot travel through that. So keep that in mind. So that is what a medium is. Whatever the wave is traveling through. So transverse waves. This is like the demonstration here with the string. A transverse wave is a wave in which the disturbance is perpendicular to the direction the wave travels. So if you were able to flip that, let me go to your book here. It shows you a little different picture. So if we just can move our rope to make just this one single wave, it doesn't just stay right here. It's going to travel, that wave, it'll travel towards the end of the rope there. So that is the direction that it's going, and that is perpendicular, or totally opposite. You know, perpendicular, remember in math, makes you plus sign. So you move, the wave is actually going up and down, but it's traveling perpendicular, which would be horizontal. So vertical, it's going up and down, it's vibrating up and down, but it actually travels horizontal. So that's perpendicular to the movement. Okay, don't let me get ahead of myself. Let's go back to our questions here. Number 5. In which direction is the wave in the figure moving? So you were supposed to put that it's moving this way to the right, towards the doorknob, however you wanted to say that. How do particles move in a transverse wave? They move perpendicular to each other. Or you could have said like opposites from each other. So here again are these answers. Number 5 to the right, number 6 perpendicular to the direction the wave travels. I'm gonna we'll go ahead and read this. We'll come back to this in the other assignment. You had to identify this. So we've got this wave up here. You have sometimes when you see these pictures, there's an imaginary line drawn through the middle. That's kind of like the starting point, the resting point. If you held this string straight, it would be on this line. And when we make this wave, we have things, you know, the wave goes up and down, up and down. The top, the highest part away from here is called a crest, like the crest of the mountain. The lowest part is a trough. You know, if you think of a feeding trough, it's shaped, you know, where it can hold food. So the trough is down here at the bottom, so it can hold something. Okay. Next page has a spring. Now, I've got a big slinky, and I didn't get it out, but I may try this and film it, let y'all see it later. Maybe you look at these pictures. This is a little different. This is a longitudinal wave, so we're not making the slinky go up and down. You got to move it this way, like, you know, this way, back and forth this way on the horizontal. And so if you move it, if you can spread it out a little bit, move it once with one hand. Let's see if I can show you. Move it once with one hand. Then, you know, the cord where it's kind of bunched up is going to travel. It's going to, that little part that's moving together and back apart, it'll travel down through that slinky. We're just going down through there. Now, if you tie a little piece of yarn on that slinky, you'll see that yarn move back and forth because it's these compression. The compression is going to come by and making it move, and then the refraction, which is what's spread out, you know, it's going to kind of make it move back and forth. When that wave, or that one little compression part and the refraction goes through, here's your wave with the compression and the refraction. When it goes through and it's already done, you get back to just your slinky, and your little piece of string is going to be back where it started from. So these are longitudinal waves. Longitudinal wave makes a particle in the medium move parallel to the direction that the wave travels. So you made that wave pushing this way in the horizontal, that's the way it keeps traveling. Now, well, I'm making ahead of myself, but sound is more longitudinal. It's going to be a longitudinal wave. If you've seen animations of sound waves, you know, bursting out, you'll see that thing, you know, kind of looks like a big wad of stuff, and here it goes. I mean, it's going in the same direction. that it was produced in. So it's parallel. That's longitudinal waves, not your up and down traveling in different ways. These are like a burst of things going through, like your slinky movement. Okay, so let's look at these answers. Number 7. What is the medium through which the longitudinal wave is moving in this figure? The medium is the spring itself, so you were supposed to put a spring. And number 8, how do the particles move in a longitudinal wave? It's parallel, or you could put in the same direction. So 7 and 8, a spring parallel to the direction the wave travels. In other words, it's in the same direction. Okay? Let's go on. I don't want to bore you to death. I know you've read this. We've read this twice now, hopefully. Alright, so on this page, and in your book, and I'm going to show you a picture in the book, it gives you a little bit more detail here. So this didn't. So if you do happen to have your book, you can look at it. If not, that's fine. We're going to go into detail in the other lessons on the different types of waves. You come back, actually, you know, if we do this long enough, we'll come back to electromagnetic waves in a whole other chapter. We have a whole other chapter on sound. So, it's fine, but this is just kind of, it kind of summarizes a lot of things here. So let's go look up here at the top. Let's talk about vibrating. 1 wave per vibration. If you're making a transverse wave through a rope, each time you move your hand up and down, that's a single vibration that occurs. 1 vibration produces a transverse wave with 1 crest and 1 trough. Vibrations stop, but the wave keeps going on. Alright, when I stop moving my hand, that rope is not just going to instantly stop. Those waves that have already been made are keep moving along that rope. Alright, types of mechanical waves. They only can travel through matter. Sound waves, water waves, and waves made by earthquakes are mechanical waves. Sound waves are longitudinal waves, like your slinky, that travel in solid, liquid, and gas. Water waves are a combination of transverse and longitudinal, and earthquake waves are also called seismic. They're both longitudinal and transverse also. Okay, then we have electromagnetic waves, which we'll have a whole chapter on later. Light from the sun is a wave. It is not a mechanical wave. A mechanical wave cannot travel through space, but the sun definitely can. Light, I mean not the sun. Light definitely can. An electromagnetic wave is a wave that can travel through empty space and through matter. Types of electromagnetic waves. You have your light waves, radio waves, microwaves, infrared waves, ultraviolet waves, and you know, we've already done the electromagnetic spectrum where we kind of wrote that out briefly and talked about this just a little bit. Now, you might have been thinking up here when I said sound waves can't go through space, and you think, well, you know, don't get sound waves confused with radio waves. Okay, those are different. So if you were out there in space and could somehow take off your helmet for a while and yell, that sound is not going to travel in empty space. But now you've got radio waves. Okay, you're talking to your buddies in your spacesuit through your radio. The radio waves are different than sound waves. Okay, they are carrying sound. You know, we've figured out over years how to take that, use radio waves, and convert it back into sound, TV, images, and all sorts of things. But don't get sound waves confused with radio waves. Okay, they're different. Electromagnetic waves and objects. Every object gives off electromagnetic waves. The type of electromagnetic that an object gives off depends mostly on the temperature of the object. Objects near human body temperatures give off mostly infrared waves. Now, you've seen this too in movies, different things. You may even have some infrared goggles. This is, you know, where you can, you know, they'll look, well, hunters use infrared at night to see things, but, you know, on crime shows and different things on TV, they'll have heat sensors where they can tell whether someone's actually in the building or not, because bodies that are alive give off heat, and that heat is in infrared waves. So your infrared goggles, you know, can pick up those images so you can see animals and humans, the outline of those at night. I think there's a picture of that in your book too, and I'll show it to you in just a minute. Electromagnetic waves from the sun. Like all waves, electromagnetic waves carry energy. Scientists often call this radiant energy. Infrared visible light carry waves about 92% of the radiant energy that reaches Earth from the sun. Ultraviolet waves carry 7% of the Earth's energy. Alright, so let's look at 9 and 10. What produces mechanical waves? So you gotta have some kind of vibration going on. And sound is definitely a vibration. You have to make a vibration for that to work. And on number 10, identify a type of wave that can travel through a vacuum. Has to be an electromagnetic waves, because mechanical waves cannot. So number 9 and number 10. Now on your next page you saw some vocabulary. I don't think we did vocabulary for chapter 4, so and we won't now, but make sure you know compression. Of course, compression, you push things together. But on a wave, that's actually in that, kind of like your slinky. You think about your slinky wave. It's where those things are close together in that slinky. Crest, think about your transverse wave going up and down. It's the top, the highest point. Electromagnetic wave can travel through space and through matter, both of those, like the sun and light. A longitudinal wave is like that wave in that rope. It's going to move. No, I'm sorry. I'm going to mess that up, didn't I? Longitudinal wave is like your slinky. It's long, so I guess maybe we got to figure out how to remember this. Longitudinal wave. Think long, I guess, like your slinky. You make it long and short. It's making those compressions, so it is moving in the same direction. So it's parallel. Mechanical waves only require matter, so they can only move through matter. Mechanical for matter. Medium is what it's traveling through, and the medium can be empty space. It can be air, or it can be something. And it can be water. Rarefaction, which I always mispronounce, but rarefaction is on your slinky part again, where they're spread out, not where they're compressed. So you just kind of think about that as opposite of your compression. Transverse wave. This is your transverse, like you're transversing it. Your transverse. How can we remember that? It's traveling. You think of traveling. That wave is traveling along that string. So the wave itself is going up and down, but the movement, how it travels, is perpendicular. Trough again is the lowest part of a wave. And of course a wave is a disturbance that transfers energy from one place to another without transferring the matter. Now number 1, you were supposed to make a sentence describe some of the differences in transverse and longitudinal waves, and then you're supposed to do the little Venn diagram with sound waves and electromagnetic waves, which sound waves is a mechanical wave, and both of those together here. And here are some possible answers for that. Transverse waves have crests and troughs as particles move perpendicular to the wave's direction, whereas longitudinal waves have compressions and rarefactions as the medium moves parallel or in the same direction as the wave. On number 2, sound waves are mechanical, they're longitudinal. On the other side of your Venn diagram, electromagnetic waves can travel through empty space. They're radiant energy. Every object gives off these waves. They have different wavelengths. In the middle for both, they can travel through matter and they carry energy. That's just examples. You may have come up with more or less. Alright, getting into this stuff for after you read. Now, you had this page here that I would expect you to do this, but you could kind of think about what you've learned as we go through here. And it lists vocabulary for the whole group there. Alright, let's go to this now. I found this on page, if you were using your book, that's what the page number I think is going to be your book. Let me check that. Yep, they may be the same. Okay, your book page numbers and this material here is actually the same page number, so you might have got this right. So this was found on 124 and 125 here. Characteristics of waves, how they move, they spread out in all directions from the source. What do? They transfer energy. What they do not do is transfer matter. Okay, think about the rope. Okay, the energy is making that rope move. The rope itself is not being taken from one place to the other. It's not originating somewhere and ending up somewhere else. So don't let this confuse you, but that's like, okay, I didn't shake that rope and then something grabbed that rope out of my hand and take it all the way to the doorknob and it ended up at the doorknob. No, the rope is still, I'm still holding the rope when all this is through, but the rope moved. The energy, made that rope move up and down and the wave travel along it, but the rope itself wasn't taken from someplace and moved to something else. That's kind of what this is talking about. So it does, energy is going on, okay, not transferring things. Alright, describe your own word how water wave transfers energy but not matter. Here's a sample answer. When an object hits the water, it exerts a force. This force transfers energy to the water by pushing and pulling the water particles. These particles then push and pull on neighboring particles. Pushing and pulling transfers energy outward from the point of impact. Okay, so it makes energy. You could put, it makes little waves, but like if you drop a pebble in a thing of water, you get the little waves, but in a little while the water's still there. It's just something making it move. Alright, down here, identify the medium through which a mechanical wave can travel. So it can go through solids. You can hear through a wall. It can go through liquids. You can hear in your swimming pool. Not the best. Might be distorted, but you can hear. And definitely gases like air, sound can go through, but it cannot go through. And I'm saying sound because it's just an example of mechanical waves. All mechanical waves, they cannot go through empty space though. Alright, so we were supposed to label this mechanical wave here, the transverse wave, with crest and trough. So you should have put crest up here. Crest will be at the top. Let's mark on this. Here's your crest, here's your trough. Okay, in the longitudinal wave, which think about your long slinky. Okay, this where it's spread out, we call the refraction. This that is close together, it's all compressed together, is our compression. This is making our wave. This is our one wave. Okay, here you could say you start at the bottom, you go up, you come back to the bottom. This is one wave. Alright, next page. This is found on 26, 27, and 28. Alright, describe how the particles in each wave move. The transverse wave, the disturbance is, and the particles move perpendicular to the direction of the wave. Longitudinal, they're moving parallel, or in the same direction as the wave is moving. Right here, a wave is produced when something vibrates. Each vibration produces a wave. Waves keep moving even after the vibration stops. Okay? So again, shaking that rope will give you that. If you did just one wave, when you quit, that one wave doesn't instantly stop. It keeps going down through there. It's like sound. When I yell something, it's out there, I can't make it stop and come back to my mouth. Okay, or just stop and just stay there in space, in air, and freeze. Okay, the sound is gone. Once it leaves your mouth, it's gone. And it's just keeping on out through there until it dies. Alright, here at this bottom part, we're putting these numbers into these different things. Okay, so I guess I'll just start with sound waves, and the numbers that all fell in here. Okay, you were not supposed to put 3 and 4. Alright, no, it says except 3 or 4. Let's read them. Alright, sound waves. They can travel only through matter. That's true. They travel through gas. That's true. Travel through liquid. I don't know why they said except 3 and 4. That's true. They travel through medium solids. Yes. They're caused by vibration. Yes. Sound waves are longitudinal waves. So yes, but you don't want to put 7. Okay, so 7 would not go under here, and it's not a combination. So over here, 6, 7, and 8, you definitely can't put all of these. Well, except for the seismic earthquake waves, they're going to be different. But for usually they're going to be one or the other. This here would be like light, but we don't have electromagnetic waves. Alright, so this one was everything but 7 and 8. Water waves. Now water waves, just because we're going through water, it's not going to be a gas or a solid, so you're not going to put 2 and 4. We're going to put 1, we're going to put 3 again, we're going to put 5, and it is a transverse. Well, no, it said water was a combination of both, so we're going to put 8. Now seismic waves, it did not. We'll come back and talk about these a little bit more, and there's a picture in your book. Let me show you what they're saying here. It's got 1, it's got 4, it's going through a solid, because these are talking about earthquake waves. Let me show you the picture in the book. Here we go. And it kind of makes a little more sense here with your seismic waves. Something happens below with this fault going on inside the earth, so that's why it's a solid. It's coming up through the earth. But they're radiating out in all directions. Okay, they're mechanical, but they're going through solids. They're radiating in all directions, and they can be all both types of waves. So they're kind of a little different. So they put 6, 7, and 8. I guess you could have just put 6, 7, and 8, because some of them at certain points they're not the combination, they're going to be one or the other. So seismic waves kind of encompasses several waves. Okay, next, if you've got any questions, if y'all do have questions, there's comments when you watch this video. You got a question for the class, for me, put it on that comment out there in Google Classroom, and we'll try to get a good answer back on there. Y'all can answer each other if you need to, but now remember, we don't just talking to each other. Y'all can use your phones for that. Alright, here we go with page 128, electromagnetic waves. Radiant energy, carry energy, often called radiant energy. They travel through empty space and matter. It's emitted by all objects, with the infrared stuff and different examples. So examples of this, you could have put other things here, but light, heat, radio waves, infrared waves, X-rays, gamma rays, any of those things in that electromagnetic spectrum. Here you're supposed to identify true and false again. This first one was false. Electromagnetic waves can't just travel through empty space like light. And of course light travels through air too, so that's not empty space. So it has to be both empty space and matter. Make sure you remember that. If you think of electromagnetic waves and you're thinking light, light is right here now, and this is not empty space. So it's got to be both. We get it from the sun though, so it has to travel through empty space. Radio waves, all that stuff is here and right here, so they can definitely travel through both matter and empty space. The next one was also false. It's not ultraviolet waves here. It would be the infrared waves. And this last one was true. Like other waves, electromagnetic waves carry energy. Down at the bottom, analyze it. You are with a friend in the schoolyard. You rest your ear against a metal leg and your friend taps it. You hear the tapping. Describe the wave. Is it longitudinal or transverse, and what type of medium did it pass through? Look at your answer the wave was a sound wave, so it's longitudinal. The medium would be, you could have put the metal leg of the swing, which is a solid. It passes through a solid. Okay? So it is longitudinal, and it's passing through a solid, which you could have been specific and put the metal leg. And we are finished with lesson 1. Yay! What you will see next is I will put a quiz. You've actually done this quiz before, but you did not get your answer. I didn't go over it because it's some of that stuff we did right at the end. You didn't even get it back, some of you. I'm not sure if anybody got back. I know 7th period did not get this back. Some of you might have gotten it back. But anyway, you're going to have a short quiz. It's very easy. Of course, you can use this material. You're there at home. But you might want to try it without it, and then go back if you have a question on something, look it up in your papers or whatever. It is a Google Doc, and it is just a straight Google Doc. So you should be able to type your answer in. It's multiple choice and matching. So it's just typing a letter in. And once you do that, of course, Google Docs is saving that, and it's going to send it. Make sure you turn it in to me, because I just want to see how you did. Then we'll go over this in another video. I'll show the answers, or I may just provide the answers to you. I don't know yet. Probably do another little short video and talk about it. But make sure when you submit it, you turn your work in. I think you have to hit a button twice to make sure that it's actually turned in. So pay attention and make sure it's actually turned in. It'll tell you that it is turned in. There's actually an option then to unsubmit it if you say, oh, I turned it in, I know I messed up somewhere. At any point you can unturn it in, unsubmit it, fix it, and turn it back in. So I'll put that out there with instructions. Hope y'all have a good day. Hope I haven't bored you to death. This has been like 30 minutes long, which is probably too long. So I may try to split this up into different segments for next week. Hope y'all are enjoying your day. It's going to be a beautiful day today. Get out in the sunshine. Love y'all.